This is the version of example 7 if you've got a black and white calculator or a coloured calculator which hasn't been updated. So you need to be able to apply what you learnt in the previous video to a real life given situation. So here a spinner is designed so that the probability that it lands on red is 0.3. And Jane spins a spinner 12 times and she wants to find these probabilities. So the first thing that we need to do in any of these questions is define a random variable. So here we're interested in the number of reds that we get when we spin the spinner 12 times. So let's write that down. Our random variable x is the number of reds after 12 spins. Now we know that we're counting up 12 trials results basically. So each spin is a trial and it's either red or not red. So we know that x is going to be a binomial distribution and there's 12 trials because we're doing 12 spins. And the probability of success here, because we're counting the number of reds, the probability of success is basically the same as getting a red. So that would be 0.3 as the probability. Or in part A, we want the probability that no more than 2 reds occur. So we want the probability of x, the total number of reds, being, well, if it's no more than 2, that means that we're allowed to have 2, but it has to be less than or equal to 2. So here on our calculators, we can work out this probability. This is a cumulative probability question. So I always draw out a diagram to help me double check that I've got the right probabilities here. So this is the number of successes that we could have. We want to add up all the probabilities of x being less than or equal to 2. So we want to include 2 and we want to go down to 0. Well, our calculator can do that because our calculator can add up probabilities starting at 0 and going up to a value that you give. So we're going to go to our calculators, we're going to go on stat mode and distribution, binomial, cumulative. We're going to put number of trials as 12 and the probability of success is 0.3. That's the probability of getting a red. Now we want our calculator to add up all the values starting at 0 and going up to 2. So we're going to put x as 2. And then we get that probability, 0.253 to 3 sig fig. Okay, let's have a look at part B then. So we want the probability of having at least 5 x's, 5 reds. So let's phrase that as a probability in terms of x. Well, we want the number of reds to be at least 5. So that means we want 5 or more. So let's write it as x is greater than or equal to 5. So again, let's think about our diagram. Let's draw out the different values of x that we could have. So these are the number of reds that we could have. Well, we want the probability of x being greater than or equal to 5. So we want to include 5 and go all the way up to getting 12 reds when x is 12. Now our calculator can't add up these because our calculator always needs to start adding up at 0. So we're going to use the fact that we know all of these probabilities add up to 1. So we're going to do 1 minus, and then we're going to do 1 minus these probabilities here in the curly bracket. So the probability of x being less than or equal to 4. So let's go to our calculators and we probabilities from 0 up to 4. So I'm just going to change x to 4 and we get that probability there. And remember to use the long version of this. And if we calculate that, we get 0.276 to 3 sig fig. Part C is a little bit more complicated. So the teacher wants to use the spinner for a class competition and she wants the probability of winning a prize to be less than 0.05. And the way that someone wins a prize is they spin the spinner 12 times, count the number of reds that they get, so basically x, and if they have the required number of reds, then they're going to win the prize. So the important thing to realise here is that they need to get the required number of reds or more. So for example, if the teacher said that in order to win the prize you need 9 reds, then everyone who gets 9, 10, 11 or 12 reds will win the prize. So here we're making the assumption that actually we want the probability of winning a prize to be as close to 5% as possible, but no more than 5%, because it says less than 5% or less than 0.05. So we're just going to have to do a bit of trial and error here. And actually part B has helped us out. So let's say, let's try and say if you need 5 or more reds to win. So let's just guess and say you need 5 or more reds to win. Well, we've actually already worked out what the probability of someone winning a prize is. So here, the probability of someone winning is just going to be the probability of X, the number of reds, being greater than or equal to 5. Because remember, if people win 6, 7, 8, all the way up to 12 reds, then they would still win because they have the required amount, which is 5. Now, we've already worked out what this probability was. It was 0.276. So the probability of winning a prize here is just too big. So we need to make it more difficult to win the prize, make the probability of winning a prize less. So let's have another guess, and let's say if you need 6 or more reds to win. So the probability of someone winning a prize here, 6 or more reds, the probability of winning would be the probability of X being greater than or equal to 6. X is the number of reds being greater than or equal to 6. Now we can work out this probability quite quickly again. I'm just going to draw out a little diagram. So 0, 1, 2, 3, 4, 5, 6, 7. Now we want the probability of being at 6 or higher, so it would go up to 12. Well, our calculators can't do that because our calculators, when they do cumulative probability, only can start at 0. So we're going to have to do 1 minus then this probability here from 0 up to 5. So 1 minus the probability of X being less than or equal to 5. So let's work out what that probability is in our calculators. So we're going to go to distribution, binomial, cumulative, and I'm going to put X as 5. Make sure it says CD at the stop for cumulative. Now, when you're on the cumulative mode, that's going to add up all the probabilities starting at 0 and ending at 5. So if we work that out, we get that probability there. And I'm using the unrounded values to get my most accurate answer. And let's round to 3 sig fig, and we get this as our probability. So here, if we require 6 or more reds to win, it's still too easy to win the prize. But notice that the probability is going down because we're including less probabilities. So let's go up to needing 7 or more to win. So let's try that. So the probability of win in this case will be the probability of X being greater or equal to 7. And I'm not going to write out the diagram again, but you can. That would be equal to the probability of 1 minus the probability of X being less than or equal to 6. So let's change X to 6 in our cumulative, and we'll do 1 minus that answer there. So that's 1 minus 0.96139915, and if we work out that, we get 0.0386. So this is the first time where the probability of winning has gone less than 5%. Now we're assuming that she wants the probability of winning to be as close to 5% as possible, but not over 0.05. So we always need to conclude in the context of the question, she needs to require 7 or more reds to win.